today's training will be on 3DExplore, which is a supplementary product to Intrepid. Well, it's part of Intrepid, but it's what's used to display data sets, give you visualization of data sets, and also let you look at the data itself. Replaces a lot of the older tools that Intrepid has had for many years. I'll just give you a quick overview. In this directory here, we've got like a few samples which launch 3DExplore with some kind of pointing it at some data sets. So you may have already learned a little bit about how Intrepid uses task files to execute the tools, lets you do batch processing of data sets and so forth. And 3DExplore also lets you do launch them through a task file as well, even though that's not the only way you can do it. That's just a convenient way sometimes if you have a process that you always want to look at the answer from. So for example, I'm going to look at this one, 3DExplore map view example now. If I just run or open the task file, it's going to launch 3DExplore for me because that's built into the task file. Just a convenient way of doing some of these demos. Okay, so what we've got here is launching up a map view of a grid and a line data set. Just run you through some of the features. On the left here we have what's called the workspace, which lets you have multiple data sets. Like it's a container for the views of the data sets that you're currently working on. So it lets you have multiple views open at once, and also gives you a frame of reference if you want to look at data a different way. So in this example, we've got a map which has a grid and a line data set. We could right click on the map here and view the data set in a table. And it's popping up on the other screen I've got here. Sorry, I'm just drag things across as they pop up. So it lets you look at that line data set as a table view, pretty much like the old DB edit tool that's been around for many years with Intrepid. This is now the more modern replacement for that. Just run you through some of the features of this particular view, the spreadsheet view. As you can see, it's primarily based around line data sets. That's probably the most common data set being used that you'd want to see. So we have navigation controls here on the top right corner, which facilitate being able to look at those data sets. So you'll be able to see here, this particular data set's got a group by online, so flight line. So you can see that all like this first page of data is all one line. You can use like the controls up the top right here to advance by a whole line and then see the data forward and back through lines like that. Also giving you the context of where it is in the whole database itself. One of the good features about 3DExplore is its ability to sort of coordinate the navigation between these two data sets. Also the data set with different views. So if we were to, back here in the grid or data set mode, we could click on select. Oh, sorry, I'll zoom in on a little area and be able to select a point. It will then highlight where that is in the spreadsheet view. I'm just going to quickly set this up differently. This background, when we click on this little cog icon, we can configure the view that we're looking at. As you can see here, it shows that there is one group of two data sets The first being this grid that's using a grayscale lookup table, and the second one is the line data set. So if we were to change things such as, we can change the LUT that's being used here to something that's a bit more colorful than usual. And we change the opacity to maximum and get a better view of this. We can actually turn off this completely as well. Maybe we just want to look at the line data set itself. I'm just going to configure the background to grey. For some reason it was set to white. Sorry about that. It's probably a bit clearer now. Some of the specific things about this which would be of interest, because this is a line data set, we can control the size of the points and stroke them depending on how big that data set is. So for example, if we were, see, things are drawn with a fixed size. So depending on the actual scale of the data set, you may wish to tweak this value here to different values to get a better view depending on what the scale of the data. Likewise, we also have, in this particular map view, we can do things like, when we have grids, we can control things like interpolation, which gives it a better view of the data, and also configure the lookup table, the LUT. So if we click on the ellipsis button here, we can actually control how the data set signal value is mapped to colors. And this, by default, what will happen is it will build a histogram of the data set, of that signal, and then distribute or create a mapping which best reflects the dynamic range of that data. So if we were to do something and like here, change it to linear, you would see a much different result. Similarly, we can do things like clip the data to less population, like 95% of the full distribution, which is useful for like taking outliers out of the data set, or not taking them out, but actually visualizing them without outliers. You can also create your own custom ranges if that's what you'd like to do as well. For example, like you clip this to specific ranges. Interested in a particular data band range. Just reset this now.
Sorry, can I just ask a question with that menu you had? There's a data clip and a visibility clip. Does the visibility clip make part of it transparent? Or?
Yeah, sorry, I should have continued on that. So yes, the visibility clip is in addition to the data clip. That will effectively take out the top ends or the range. So if I was to change this again to 1970 to 1980 or so, yeah, it basically makes transparent the things beyond that range. You can have a look back at the original map view here. It's quite a useful feature for doing QC. You could highlight any particular outliers, become very visible.
That's good, thank you.
Okay. I'll come back to this particular view later with some other data sets to show you more what you can do. Just thought I'll give you a quick overview of this. Next example I'm going to show you is the profile plots. And I'll show you an alternative way. Obviously, what I showed you here was running a task file to get that view running initially, but you can view any data set from just choosing it in Project Manager and then launching 3DExplore. So what I'll do now is actually just run this one. In this example, we have another line data set, but we're viewing it in the profile plot view. So profile plots basically allow us to map the data from an XY data to have a contiguous X value, such as the feed of a line data set, or it could be some other similar concept. And we have signal values that we want to map on the Y. And again, we have a similar kind of little cog icon here that lets you control how you want to display these things. You can change colors of the traces, you can move things around. So in this example, we're showing two plots in the one pane, so it's got a common shared domain. But you could also, if you wanted to have separate panes, we could take raw mag off this one and put it into this one. Also show how you can set the range to be common axis between the two. Let's see. X-axis modes, yes. Right, so going back to what we had before, there are different modes on how we control the X-axis. In this example, we've got a feed for a line data set, but we may prefer to show something different, such as so in this example, the X-axis style is field value. It's coming directly from one of the fields of the data set. I think I should probably show you that as well. So if we were to open up as a table view, you can see what the data set looks like here. We actually have a line, a feed that's ever increasing, and then some mag values here. But we also, this is an actual line, like a data set with coordinate data as well. We can visualize this as a map view by going back to this table here and creating a map. We'll be able to visualize this a different way. And by default, it's picked a signal value, which is not much use to us. It's actually picked line type, so it's all going to be the one thing. But we could actually pick the raw mag value here. This is actually the data set we were looking at before in the other view. Just now we're looking at it on a line-by-line basis in the profile view. And again, this can also coordinate. If we were to click here on the select button and click on a point on the graph, then our profile view will take us to that point. We can actually see, it's jumped us to line 2971. So that's one handy feature now. You can go back and forth between the two views as you advance lines. With the spinner up here, it's going to select the line in the map view. Similarly, within this view, there's another quite handy feature of being able to show the next or the previous line in relation to the current line. So for example, in these situations where you have a lot of parallel lines, you may want to compare two lines with each other. the profile view lets you do that. You can choose to do the previous or the next. Although this is not doing what I expected. Possibly because the x-axis is not. That's what I'm doing wrong. So because the it's using feed for the x-axis, they can't be shown on the same x-axis. You would have to choose something like xy distance along the line. So then now the domain is being, or the x-axis of this plot is now pulling it from a relative value from relative to the start of the line. So we can actually superimpose two graphs like that. All right. Take you to show you something different. So we have some airborne electrical magnetic data that I can show you. These things. Bring up another example task here, which will show us an extreme example of profile plots. This is some AEM data, which is showing multiple channels of data in one go. Specifically, this is some data from a failure tempest. So it's 14 bands of data all shown on the one graph. And by nature, this is data which could be best represented with the log Y scale. So there's a control here for changing that. You better represent the low level of data there. So far I've been showing you 3DExplore being launched from task files, but I should mention that you can actually launch it from just finding data sets in Project Manager and then launching it that way. So if we'll go to another example here, the data set that we were looking at before, the AEM data, we can click on the data set itself. This gives, in Project Manager, an overview of what the schema is for that data set. We can actually look at statistics and histogram from here. Want to drill down and look at the data itself, we can click up here in the visual menu and then go 3DExplore. And by default, 3DExplore will open any data set in the most sensible view for that data set. So if it finds that there are XY values, like it's a line data set, which would, can be represented as a map, it's going to launch the map view first. It's the same thing with grids. Grids will be launched through showing the map view of the grid. So in this example, we've got 3 lines with fairly complex overlapping data, which probably doesn't represent it well in the map view. So we can right-click on the map and view the table view of the data. The table will launch up. This shows us one of the other quite nifty features of 3DExplore is we can view some multi-band data as a graph. So this is a complementary view of what we were looking at before, where we had multiple bands of data over time or over the feet of that line. This one is showing us the individual samples at that one point in time. It's shown as a graph. So with bands on the band number, I guess, on the X and the signal value on the Y. We can right click on these columns and show it as a separate band if you wish to actually view the data, the discrete values of the data. But as data sets with huge numbers of bands get used, it's very hard to see what's going on here. So we've added stuff to let you look at the bands as a graph. If you wish to create a profile plot of that, you can right click on or click on a column and go up to the menu, create profile plot. When you create a profile plot from the table view, you're giving options here. You can choose the default action, which is just to plot that data or that column. But sometimes it's convenient to run through this wizard to do more advanced things. So we'll just run through this specific example, a multi-band. If you want to create a profile plot from multi-band, sometimes there's perhaps even 1,000 multi-band channels, and you don't want to be having to create individual traces for every band. You may want to automate the process, so you can do it through this control here. In this example, there's only 10 or so bands. It's not really that many, but you can if you did have more to step through every 10th or every 100th example to create like a more custom view, and you get something like this. So this is showing individual signals, each of these bands, over time or over the feed. I'll show another example using tensors. They also are shown as a special representation in the spreadsheet view. So let's go to tensors. Which one is it? So this data set, we have some tensor data types. We can view them in 3DExplore as well. Again, it's displaying the map view by default because it's a line data set with X, Y values. You can also look at this as in the table view. And here we can see graphical representations of each of these tensor values. We can also create a profile plot of the tensors. And this example as well, the wizard will let us choose an automatic setup of viewing that. So if we were to now pick the tensor that we were looking at, our profile plot will come up with each of the components of the tensor as their own separate graphs. The way this is working in the configuration table here is each signal can have has an associated query. So when we have multi-part data, such as vectors, tensors, we can specifically choose one of its components to plot when we require just a scalar value. When we're looking at tensors and other sorts of multi-component data in the map view, we also have the same kind of query. We can now map those components to or well, in this example, the component, if we were to pick a tensor here, we can now choose the query that results in a scalar value that is then mapped to the lookup table color. We can also have control over rendering that tensor with glyphs. So we're now to zoom in on these points here. We can enable a we can see that there are glyphs that are mapped to other tensor variables. Right. Any questions so far? Am I going too fast or too slow? I'm not quite sure.
No, the best is good. I think it's all good for me. Yeah. I don't have any questions.
Okay then.
That data looks odd. There's no correlation from one line to the next. You can see the tensor, how you had it zoomed in before, where you can see the tensor orientations. There wasn't.
Right.
The tensors were off in one direction than the other for the next line. Oh, there they look pretty good, yeah.
Well, to be honest, I'm not an expert at tensors. I really can't say. So I'm more dealing with the software engineering of this rather than the science of it. So. All right, I'll now show some examples of radiometrics data. We've got quite something we've been working on lately. There's been a renewed interest in that, and we've upgraded our processing to handle 1024 channels of radiometrics. Because previously that was 256. So we'll go to the radiometrics examples. By the way, all these examples are in the install. You can view any of these examples afterwards. This is all part of the installer. So we're going to go to tasks. Just run these tasks to produce some data, usually very quick. As we can see here, again, this is another task file which loads up 3DExplore and displays so an existing data set. This, we'll run that. Okay, so what we're looking at now are the principal components of that radiometrics data set. It shows launches multiple graphs as well, showing the different data two different ways. This way it's showing it the bands for a given line, and this one's showing the other things. Where is the data sets? I'm bringing this up so we can actually look at the camera image plot. this is a new feature we've been added recently. We can show the energy at each point. So this is showing the bands on the Y. So for each Y value here is colored using a lot across the whole feed range. So this is effectively if we look at the data in a table view. This spectrum data and this spectrum data here being mapped horizontally across, effectively creating a grid on the fly. I'm going to run through some more advanced examples of 3D data that we can view. So we go back to our previous example of Intrepid3D. Give you a better overview of what you can do within this map view, which is what is used probably most often in 3DExplore, represent 3D data. Just looking at the data set that we have here. This is a 2D grid, but we can actually turn on a Z-axis scale to that grid and rotate it. So some data sets may be better visualized using a 3D view of that data. We've currently got this to auto scale, so it scales the y-axis to a sensible amount rather than the actual discrete values. So if we were to click on the LUT, we can see that this is a very small range of signal values, but we've stretched it out so that we get a better visualization of the data set that way. So share a few examples of what 3DExplore can do. We have a look at you can view SegWi files as well. This is another example that's similar to how the gamma ray image plot is generated. It's taking the data and plotting it on the y-axis using a lookup table to give us a color value. There's not many controls to do this one. We can change the light to something else. That's what you prefer, but not much to control here. We can also look at voxels. The support of voxels is not that ergonomic, shall we say. We can actually open up voxel files, rotate them around, and clip them on multiple ranges if we want to have a look on the inside. Show things like that. Clip on multiple ranges here as well. Changed fairly recently. We were rendering voxels more as point data sets, but now we've changed it to show them as cubes.
Sorry, can you do ISO surfaces with the voxels, and then can you export it to other software?
Don't believe so. Let me just make a note of that, and I can get back to you on what we're planning to do with those. 3DExplore is mainly a visualization tool. It's not really used for changing data from one form to the other. I think we can all. I think the only parts of it that do let you change data is in the table view. So when you actually in a table view here, you can change values. There has been issues with voxels before. We're definitely trying to improve our handling of it. I'm not sure about the specific question, so I'll have to get back to you on that one. Another example of multiple grids. Another thing you can do when you have multiple grids, you can control this. You can select multiple grids, and when you launch the Explorer, they'll ask you if you wish to put them all in the same view. Just a handy way of getting all the grids in the same view, such as this. This also lets us demonstrate another feature. Each of these grids has got their own lookup table, so they're all being done within their own range. But you can actually set this up to use a common lookup table range. If we change these all to shared, then this particular lookup table now will be showing the combined signal of all the data sets. In this example, they're quite disjoint, so it doesn't quite demonstrate the ability very well, but you can just see that they are separate.
Sorry, how do you do the sun shading in that view?
Oh, right. Yeah, okay, so I'll try and set up one example for that. So sun shading is done by enabling the color mode here. And this example is using the same elevation file, but you could use a separate elevation file if you have one. don't think I have one for this. But yeah, there's multiple color modes here when you configure the value of one grid. It will use the elevation file for the height map. That can be selected from something else like a DEM.
Okay. Yeah.
And you have some control over the parameters here. So if we to change inclination to some, you change different values like that. I'll give you another example of something similar. If we look at it, go back to my page. In this example, we actually have a ternary grid using sun angle shading. So this is mapping three components of tensors to a red, green, and blue channel each. Each of those is using an elevation file to also provide sun angle shading. So the shade,
Okay.
the
So you
dark
select,
shading.
yeah. So you select the elevation for each one. Okay.
Yeah. It's actually, well, really only the first one is taking effect here. Everything's sort of controlled through the first channel.
Okay.
And these ones, it's a slightly inelegant interface at the moment. But when you're doing a ternary grid, if you enable the color mode to be ternary in this particular control, it will then take the next two data sets as the green and the blue. And then you also can enable or choose which the elevation file is. You also notice like this is using the same grid for all three channels, just different components of it. You can use three separate grids. So,
Okay. And then how would you then export? So say you got the image looking how you wanted it to, how would you export that so you can bring it into ArcMap or a GIS product?
generally do it through a
Good question, Adam. I was just about to ask that if the image is looking nice and you want to export it, how do you do that, and what are the possible formats that you can export it into?
you just do print or print to GeoTIFF through these models here.
So if you say print to GeoTIFF and then you can select the file name and all that, does it open a window? Can you if you say print?
You choose which.
Okay, then you can choose the file.
Yeah.
So it's only GeoTIFF that you can export it into?
Yeah, I mean, the 3DExplore is mainly geared around visualizing the data that you have. There's some other tools that we can within the Intrepid suite which can produce or can convert data to a presentation level. So this app does not actually let you, structure the way you want to display output it to another format as such. It's more just for visualizing the data you have for doing QC and those sorts of things.
Oh, okay.
But there are other tools within Intrepid to do that kind of work, the presentation work. Right. do some more examples. I probably haven't shown this one yet. There's another thing which shown. We have a histogram view as well, so you're able to compare data sets. Within this view, you can move the signals up and down if you want to, like control which one's first. So I mean, this is good for comparing two signals of the same data set, see if they have the same distributions. So all these things from the menu here. So one of the big features of 3DExplore is, like, in any view, you can jump to another view just by going through the menus up the top. You can go from from that view to the profile plot view, or then go to a map, depending on the situation, and it tries its best to coordinate the selections between the views. Oh, sorry, that's not what I want to do. So as you jump around in lines in one view, it will update the highlighted point on the other views. Right. All right, here's run this example, which is an unstructured mesh. Handling of this is not ideal, but does actually let you display unstructured meshes, and you should have the same controls as for the box sets if you need to have a look inside it. You know, crop at different levels. Same with this. It's another 3D. In this case, it's a dike. Same kind of controls to crop as required. So again, 3DExplore's main feature is the ability to just open up files and let you view them and combine them. So if you do have two data sets in the same physical space, you can overlay the two. You can overlay line data sets with grids or with other 3D data, bring it all into the same view in this example, like in the maps. And any questions so far? Anything specific you'd like to probably show you?
I just have a general one about the map view. Is it possible to show, for example, 3 different grids that have the same spatial area and link the windows? So for example, if you had magnetics, radiometrics, elevation, can you have 3 different windows open at the same time and have them all zoom into the same area for QC?
Yeah, great idea. Just see if I can throw up an example of that. Probably have some. Just grab some data. Okay. Let's open up these 2 data sets. So there's a couple of grids. Let's do some separate views. I believe they're. I know they're probably not the same. Hang on. This thing's getting in my way. It's zoom. Okay, I'll just use these two as an example because they seem to be the same physical space. And hunt around for better ones. Okay. So here I've got two data sets in the same range. I'll try and pull them onto the screen at the same time. One's actually the DTM. We have this feature here called Sync View. If you click on this button on, or click down this button on two views that are in the same range, it will synchronize the views so that as you zoom in on one, it will zoom on the other and keep them effectively locked together. So as you pan one, you can look at the other. Is that roughly what you're thinking of?
Yeah, that's exactly what I was after. I think that's a relatively new feature. We hadn't had that in previous versions. It's really good.
Yeah, yeah. This is something that people in house have been saying, "Oh, we really should do this." And I was actually the one that just got it done. I said, "Yeah, I'm going to do it today." Yeah, so that also is that will work between any two views, so it's not specific to grids as such. I mean, you can do the same thing with like data, like line data sets or any other data. It's purely just synchronizing the 3D view or the camera view. Same thing with like even if this is you're looking at it in 3D. If you had 3D data sets with say I turned on the 3D warping.
That's really a great tool for QCing, because when you want to compare grades, having them side to side, side by side, is easier, and being able to synchronize like that is really great.
Yeah, so it'll work even on the rotation of if you're rotating grids, or like looking at 3D data, it will keep them in sync as well. I forgot to show that off. That was on the list of things to show me.
That's good.
Never got around
James
to it.
and Adam, when we get grades from contractors and you want to compare, that's a great tool to use, I think.
Right. Pretty much it. I think I've run through things rather quickly and gone under time budget. So I'll open it up now for anything else you want me to show or explain. I didn't go through every single button. I think a lot of this is pretty intuitive. You've got controls at the top here to do things, and these inspector views also have a lot of fairly simple use controls.
I think on the plot there was is it plot spectral content?
All right, so if we were to open up probably radiometric style. I believe it's the spectral one. So if we're looking at our 3D radiometrics example. Okay. So a spectral plot is essentially taking multiple bands, plotting bands on the x-axis on domain. So if we were looking at this, the table data is Okay. So when we're looking at the data here, one sample at that point, well, I call it sample, but is it like a multi-band sample? So there'll be multiple bands of data for that one particular point, and so in the table view, we can also represent this as a graph instead of as discrete multiple bands like this. So like in this example, there's 1,000 data points in that one row, so it's quite hard to read or to make sense of. We can show that as a graph here, and so the spectral plot is essentially that same graph. It's showing for each band what the value is. So that actually changes as we navigate to different rows. It's a bit hard to show this in the background, but spectral graph is essentially the same as what we're rendering in this one particular thing, and showing all the bands for the values for all the bands for that one point. That makes sense. I'm not the best person to explain these things. I'm more of a software engineer than a scientist. So
I think that's a really useful addition. Previously, we've done a lot of that in-house with our own scripts and that sort of thing. I don't think it's this kind of visualization for radiometric data has been possible with previous versions. So I think this is a fantastic tool to help us do quality control, particularly where you had that view before, where you had all the principal components lined up next to each other and colored them with the red to blue stretch.
I guess the other thing is, if you've done radiometrics before as well, that we recently put in for the gamma ray image plot. That's what I forgot to show before. Sorry. We've also added this ability to change it to energy per bin, which gives a different view. Again, I'm not sure what that means from a science point of view, but something recently that Des and I put in. And you can also do it as, you can set up your graph to show both. If you want two different views, the same thing. All right. Okay, is there anything else? Anyone has any other questions? Or
I'm assuming there's like a document, one of those workflows or something like that explains these tools in more detail if we need to reference them later on. Is that right?
Yeah, I mean, this help the help document or the manual has descriptions of some of these, of all this stuff, definitely. Constantly being updated as we do more work on things. I think you've noticed recently, like we've overhauled our documentation from previous versions. It's all now online and or modernized from what it used to be. It used to be like one a whole bunch of disconnected PDFs, and now we've integrated it all into one website. It's always online. Same thing with our examples. We've spent a lot of time making examples and test data such as this, so you can actually get stuck into using it and seeing how it works with the sample data before you're looking at your own data. And there's always support when you need it. So well, I guess if there's no other questions, probably should just wrap it up here. Seems to have gone a little bit under budget, but I can't seem to think of anything else that I haven't shown you. So All right. Any other questions? No.
Nope,
No,
thanks, Jason.
probably.
No, all good. Thank you.
All right.
Thank you.
Thank you for your time.
And if we, yeah, Jason, if we do have questions that pop up later, I believe we can get back to you and or Intrepid
yes.
and ask you questions. Yeah.
Yeah, definitely. Anytime you have any problems, you
Okay.
can contact support. You send in
Yeah. Especially
to the
because
support.
there are some new tools in this this version, like James was saying. If we
Yep.
want to try it and then find out something that we'll need to more information about, we'll get back to you.
Yep, definitely. So yeah,
Yeah.
always just
Thank you.
contact support. All right. Thank you very
Okay.
much for your
Thanks so
time.
much.
Okay.
Thank you, Jason.
Thank you.
Thank you. Bye-bye. Bye. Bye, everyone.